Okay, students, today we have a kind of new role in the sigma. Okay, so let's first see the question. Okay, we have Pn of this long. Okay, and then we want to show that Pn is independent of A. Now first, let's take a look at Pn. It includes three sigmas. Okay, and not all of them have the same indexes. Like here it's n, here it's n minus 2, and here it's n. Okay, even here it's different. Here it's 3, here it's 1, and stuff. So let's take a look. Where is A exactly? We have A here, and we have A here. We don't have A here, or here, or here. Now let's first, okay, since the question said show that it's independent, okay, without expanding, okay, that was the original question, without expanding, okay. And what is meant by that is that we don't have to expand each term. Like we don't have to substitute r here by 3, then by 4, then blah blah blah, then n, okay. So let's first see what we can do. First, one might think that we have to like put them all in one sigma, but it's simply kind of impossible since we have different indexes. So first, we have to know what is meant by independent of A. Okay, if Pn is independent by A, then we have to know that since A is a part of Pn, we can probably take it as a common factor from different terms. Okay, so let's say after factorizing this and after simplifying it, we get the term AK plus C. Okay, and K here is includes maybe sigmas of R, maybe not. Okay, so the main idea here is that we want to prove that K equals 0. Now why is that? Because if Pn is independent of A, it means that every coefficient of A or their sum have to be 0. Now when I solve, you'll understand more why. Okay, so first let's write it down. Okay, Pn equals sigma of A 2r minus 1 minus 5. Now, as I told you first, I'll try to simplify and take all the terms that include A alone. Minus A sigma 2r plus 3 plus sigma 7. Now, of course, I'm abbreviating sigma just by like discarding its indexes, but at the end of the day, of course, I will put them back. Okay, so it is equal to sigma of A 2r minus 1 minus sigma 5, because basically we just expanded this sigma. Okay, minus A sigma 2r plus 3 plus sigma 7, which is equal to sigma A 2r minus 1 minus A sigma 2r plus 3 minus sigma 5 plus sigma 7. Okay, let's see the terms that contain A, and here we kinda made it. We just have to take A as a common factor now. Of course, this A here, since it's a constant, we can just put it here. So it's A times sigma of this thing. Okay, so it's A sigma 2r minus 1 minus sigma 2r plus 3. Okay, minus sigma 5 plus sigma 7. Now, about these sigmas, we don't really care much about them because we want to make Pn independent of A. Now, let's take a look here. This is Pn, okay? It is in the form of a times a certain coefficient, which is here these two sigmas, okay, plus a constant or anything else that is not included in A. Let's name it C, okay? So here we have to know that for Pn to be independent of A, the coefficient of A shall be 0. We shall prove that it is 0. So here we have to prove that this term equals to 0, okay? Then we will have solved this question successfully. Okay. Let's take these terms and work on them. 2r minus 1 minus sigma of 2r plus 3. Now, of course, we want to see the indexes of the first sigma and of the second. So 2r minus 1, the indexes were r equals 3n, and for the 2r plus 3, there were r equals 1 and n minus 2. Okay. R equals 3, n, and r equals 1, n minus 2. Okay, now for the real question and the hardest one. How can we possibly prove that this term equals to 0?
Now let's see and think carefully here. What can we notice about these sigmas, about especially these r's and n's? What is common between this family of r and between this family of r and n? The difference is that this one is two steps ahead of that one. Or in other terms, the difference is two. Now what I mean by this is that this family here minus 2 equals this family here, you know? So this is two steps earlier than this one. So can we link them since they have the exact same like idea? They both end at n and start at r, but they are only two steps ahead. I mean, there are only two steps like in difference. So can we link them? That is the real question.
So what we want to do is that we want to introduce a new index. Let's name it k or s or anything. Let's say k equals r minus 2, since we want to apply this index here. So since k equals r minus 2, we want to see this r, it's equal to what in terms of k? R equals k plus 2. If r equals 3, then k equals 1. If r equals n, then k equals n minus 2. No, no, yeah, okay. Okay, so we just wanna put it here too. We rewrite this as sigma of k equals 1 and it reaches n minus 2 of 2r minus 1. Now, if you notice, this one we have to also transform it. So r equals k plus 2, therefore 2r plus 2r minus 1 equals 2k plus 2 minus 1, which is essentially 2k plus 3. Okay, so we write this 2k plus 3 minus r equals 1 1 minus 2 2r plus 3. Okay, now as you've noticed, we only transformed the indexes, but will this genuinely make any sense here or make any difference here? Let's see. Like what I meant is that if we have one sigma in terms of k and the other in terms of r, can they like sort of like react with each other or not? We have to know that the indexes or this variable is basically irrelevant because it only indicates where to start and where to end. Like here, k equals 1, so the first term is basically 5. Here too, if r equals 1, the first term is 5. If k equals 2, the second term will be 7, and here too it will be 7. So since we have the same starting point and the same ending point and we have the same function, therefore if we um, deducted them from each other, we will get 0. Therefore Pn equals therefore Pn equals a times 0 plus sigma 7 minus sigma 5. Now sigma 7, the index is where r equals 3n, and for the sigma 5, it was r equals 3 and n2. Therefore, Pn equals the sigma of 7 minus 5, r equals 3, and or basically sigma of 2, r equals 3, and which is completely independent of a. Okay, we solved the first question. Let's see the second one. Find then if Pn equals 20. Okay, since Pn equals 20, therefore sigma of r3 and 2 equals 20, and of course we want to write this in terms of n, so basically we just put 2 multiplied by n minus k plus 1, which is basically n minus 2 equals 20. Therefore 2n minus 4 equals 20. Therefore 2n equals 16, n equals 8. Evaluate Pn plus this thing, okay. So Pn, it's meant here by the result in which it's 20, okay. So 20 plus the sigma r equals 1, 4, 3r minus 3r. So it's 3, 1 minus 3 times 1 plus 3 squared, 4, which is basically, of course, a constant, plus 20. This will be the answer. And for the final part, find the integer m for which, okay, let me just clear things up. Okay, find the integer m for which sigma r equals m plus 4, 2r minus 1 equals 45. Let's see how would we solve this question. Okay, so we just substitute every m in r, plus 2 of m plus 1 plus 4 minus 1 equals 45. Now after expanding and adding and subtracting, we will get 10m plus 15 equals to 45. Therefore 10m equals 30, m equals 3. That's it. And just a small comment for this question. Okay, 2n minus 4k, I accidentally subtracted 4 from here instead of adding it, so it's actually 2n equals 24, therefore n equals 12. And that's it. Just the main idea of this question is to know when and where to swap the indexes and to create new ones here, as we saw when we created the new index k in order to eliminate these two terms. And thank you.